All right, in this video, we're going to practice some trinomial factoring, but we're not going to use any regular old trinomial factoring strategy. No. Some people call it the tipping method. Some people call it the roundhouse kick method. I like to call it pure awesomeness. And I'm going to show you how to use this strategy to factor trinomials. And we're going to start with this example right here. Now, the thing you need to know about this strategy is that it really is best suited for when the value of a is not equal to 1, like this trinomial. We've got a 2 sitting there. And the way we apply this strategy is the same as most factoring strategies. You start by looking for two numbers that are going to add to get your b term. And our b term in this case is 5. But the two numbers we choose also have to multiply to give us a times c. And in this case, that's going to be 2 times 2. A is 2 and c is also 2. So 2 times 2 is 4. So we're looking for two numbers that are going to multiply to get 4 while also adding to get 5. Okay, hardest part of this strategy right here. But I find if you start by looking at the multiplication first, things are a little easier. I know that 2 times 2 is 4, for example, but 2 and 2 will never add to get 5. So 2 and 2 aren't going to work. So let's pick two other numbers that multiply to get 4. And the only ones I can think of would be 4 and 1, right? And I know that 4 times 1 is 4. And then I also know that 4 plus 1 is equal to 5. Okay, so 4 and 1 are two numbers that will satisfy both of those conditions. So what is this strategy and why is it so awesome? Well, it starts by taking the two numbers you just found, 4 and 1, and just sort of writing them wherever you want to on your page. I'm just going to pick right there. And the next thing you're going to do is you're going to take the value of a, which is 2, and we're going to just randomly sort of divide each of those numbers by that 2. And you're going to end up with some fractions. So right away, you're like, well, this strategy is not for me because I hate fractions. But I promise it's going to be worth it. Okay, so we're going to take our fractions and we're going to reduce them to lowest terms. So 4 over 2, that's just the same as 2. But I need a fraction here, so I'm going to call it 2 over 1. Okay, I've reduced it to lowest terms. 1 over 2 is reduced to lowest terms already. Now here's where people start naming this strategy the tip over strategy, or as I like to call it, the roundhouse kick strategy. And the reason for that is you're going to take each of the reduced fractions and you're going to roundhouse kick them or tip them over from left to right so that the numerator lands next to the denominator. And let me show you how that looks. The denominator in this case is 1 and the numerator is 2 and it's a positive 2. So I'm going to write the sign with it. And I promise that that's important and you'll see why in a moment. And I'm going to do the same thing for the second fraction, right? 1 over 2. We couldn't reduce that fraction, so we're going to use it. We're going to roundhouse kick it or, tip it from left to right. Keep the denominator the same, keep the sign with the numerator, and we end up with two random pairs of numbers that don't really mean anything at all. Remember, we were trying to factor here, so what are we even doing? Well, I promise it's going to make sense in just one moment. The last thing we're going to do is we're going to put some brackets around these random pairs of numbers, and we're going to place an x next to the first number in each set of brackets, and you'll see that we end up with a factored trinomial. All right, so we ended up with 1x plus 2 times 2x plus 1. And if you don't believe me that worked, you can check your answer just by sort of multiplying this out. And I've just done that for you here to save you some time. And you'll see that this trinomial is equivalent to the original trinomial, meaning this factoring strategy works. And I promise you it will work every single time. Even for this trinomial, you might be thinking, even for this trinomial. But before we get into this example, be sure to trinomial factor that like button if you're enjoying this video so that other people can learn this crazy strategy as well. So looking at this trinomial, you can see that the value of a, again, is not equal to 1. That tells us we can use this crazy strategy. And we're going to start, like last time, by looking at the value of b, which in this case is -7. And we're going to find two numbers that add to get -7. But those two numbers also have to multiply to get whatever 3 times 4 is, which we know is 12. Okay, so those are our two conditions that we have to satisfy here. We have to find two numbers multiplying to get 12, but also adding to get -7. A little bit of a trickier example here because we're dealing with a negative number, but if we start by looking at the multiplication, I promise things are going to be okay. We know that, 12 times 1 is 12, but there's no way those numbers are adding to get -7. The next one that comes to mind is 6 and 2, but those aren't going to add to get 7 either. So I'm going to just pick on 4 and 3. I know that 4 times 3 is 12. So that is one of our conditions satisfied right there. 4 times 3 is equal to 12. But the other condition, adding to get -7, would not be satisfied because 4 plus 3 does not equal -7. So in order to get -7, I can make both of these numbers negative. I can take -4 and I can add -3, and that's going to give me -7. And when I make 4 and 3 negative, I also get positive 12. So the two numbers that I want to work with in this case are -4 and -3. Okay, hardest part of this factoring strategy is that part right there. With a little bit of practice, you'll get it. So what do we do with these random numbers? We take our -4 and our -3 and we simply write them somewhere on our page. And remember, we just randomly divide by the value of a, which in this case is 3. Okay, so we're going to end up with two fractions And you'll recall that we want to reduce these fractions to lowest terms. Negative 4 over 3 is already reduced to lowest terms, so we'll leave that one alone. Negative 3 over 3, well, that's just the same thing as negative 1 over 1. And now we've got two fractions that we can roundhouse kick or we can tip over or whatever you want to do to them. Starting with this first one, if I keep the denominator where it is and I tip that negative 4 next to it, I'm going to end up with this pair of numbers. And if I do the same thing to the second fraction, I keep my denominator of 1 where it is, and I'm going to tip that negative 1 next to it, and I end up with this pair of numbers right here. Now remember, the last thing I need to do is somehow make a factored form expression out of this nonsense, so I'm going to slap some brackets around each pair of numbers like this, and I'm going to place an x next to the first number in each set of brackets, and you're going to see that I end up with a factored form expression, 3x minus 4 times x minus 1. And again, if you don't believe me that this works, you can check your answer just by multiplying out each term inside the brackets, and you'll see that you do in fact get that original trinomial back again. Now, I promise you, this strategy works every single time. It's a bit of a strange strategy. It takes a little bit of practice, but to help you out with this, I've put a link to a free worksheet in the description below that you can use to practice. And if you're curious to see more of this strategy, you're going to want to head over to this video right here, and I will see you there.